The critical path method. We're going to do an exercise now. We see 6 activities. Within each one of these, we're going to look at specific critical path rules and calculate the earliest that each activity can start and the early finish. Once we get to the final activity and we have an early finish date for the entire project, we will do a backward pass, and that will tell us the latest that each activity should finish and the latest that they can possibly start. Once we have established all of these numbers for all 6 activities, we can go ahead and calculate float. We'll be using what is called a day 1 start. The way I like to explain this is the earliest that we can possibly start any activity that does not have a predecessor would be the morning of the first day of the project. Now, to figure out the earliest that we can possibly finish this first activity, we're going to take this early start and we will add the duration of the activity. In this case, it'd be 1 plus 5, but then we're going to subtract 1. The reason that we are subtracting 1 is we are using entire units of time. So if we're starting on the morning of day 1, we're using all of day 1. So if we have 1 plus 5 minus 1, it'd be early start of 1, early finish of 5. If we look at this in terms of a work week of Monday to Friday, we're starting Monday morning, working all day Tuesday, Wednesday, Thursday, and finishing on Friday evening. So if our early finish is 5, that means that we have also fully consumed day 5. Having fully consumed day 5, the earliest that we can start a successor activity, in this case activity B, would be the morning of day 6. We're going to use the same rule here. So we'll do 6 plus 10 minus 1 gives us an early finish of 15. For activity C, because we only have one predecessor, in this case activity A, that finished on the evening of day 5, we can start activity C on the morning of day 6. Adding a duration of 12 takes us to 18, minus 1 brings us back to 17. So this is pretty easy when we have just one predecessor activity. And let's look at this one more time with activity D. One predecessor. So we just have to go ahead and say we will start the morning after the early finish of the predecessor. So in this case, it would be the morning of day 16, plus a duration of 15, minus 1, the early finish would be 30. Now with activity E, this is where we really have to look at rule number 2 here. We're going to be looking at the latest early finish of the predecessor activities, because we see that all of these activities are finish to start relationships. So both activities B and C must finish before activity E can start. So we have an inability to start on the morning of 16 because activity C cannot possibly be finished by then. So by going with the later number, in this case the early finish of 17, and then going to the next morning, we would have an early start of 18, plus a duration of 4 takes us to 22, minus 1, back to 21. We have our final activity, activity F. We're going to look at the latest early finish of a predecessor activity. In this case, it would be activity D with the early finish of 30, and we will add 1, so it's going to be the next morning. 31 plus 8 takes us to 39, minus 1, early finish is 38. To do a backward pass, there's 2 ways to establish the late finish for the project. If we have an externally imposed deadline, for example, if we were told that we have 45 days to complete all project work, then we would say that the late finish for the project would be 45 days. Lacking an externally imposed deadline, and it'd be very obvious if you have this in a question on the exam because they would just have to basically tell you that you have a deadline of so many days. Lacking that, you're just going to take the early finish of that final activity and transfer it right down and say that that is also your late finish. This will allow you to go ahead and calculate float and determine your critical path. We're basically going to do the opposite of what we were doing previously. So to calculate our late start, we're going to start with our late finish, subtract the duration, but then add 1. So we'll do 38 minus 8 plus 1, which would give us 31. Our final rule for the critical path method as we are doing the forward and backward paths. So the late finish of a predecessor, the way that we will determine this, we're going to take the late start of a successor and then minus 1. So in the case of activity F, we have two predecessors, activities D and E. Both of them just need to finish before activity F can begin. So as long as they're both done by the evening of day 30, it doesn't matter if they're finished 4 days prior to that or on the evening of day 30, because that will allow activity F to have its late start on the morning of 31. So for activity D, we see our late finish is 30, and activity E, late finish, is also 30. Again, using that same basic formula of late finish minus duration plus 1. So for activity D, we have 30 minus 15 plus 1 gives us a late start of 16. For activity E, we have our late finish of 30 minus 4 plus 1 gives us a late start of 27. For activity B, now again, when we're doing the backward pass, we're going with the earlier of the late starts when we have two successors. The forward pass, we go with the larger of the two early finishes. With the backward pass, we're going with the smaller of the two late starts. So activity D and activity E, we have a late start of 16 and a late start of 27. If we go with a late finish of 26, well, we'd be way past the late start of activity D. So we do have to go with these smaller numbers each time. So for activity B, we have a late finish of 15. We will subtract 10 and then add 1, and that will give us a late start of 6. For activity C, we only have one successor, so we simply have to finish the evening before. In this case, we will have a late finish of 26. We will subtract the duration and then add 1, give us a late start of 15. Finally, with activity A, we have two successor activities. We need to go with the smaller of the two late start dates. So 6 and 15, we will go with 6. We just need to finish the evening before. So the late finish would be 5. Then we will subtract the duration and add 1. That will give us a late start of 1. Calculating float is incredibly easy. Basically, all you have to do is subtract the late finish minus early finish, and that will tell you the float. So for activity A, late finish minus early finish, 5 minus 5 is 0. For activity B, 15 minus 15 is 0. Activity D, 30 minus 30 is 0. Activity F, 38 minus 38 is 0. Activity E, 30 minus 21 is 9. And finally, activity C, 26 minus 17 equals 9. So we do have some critical path rules. The critical path is always going to be the longest duration from start to finish throughout the entire project. So it's going to be the sequence of activities going from left to right, all the way from the beginning to all the way at the end of the project. Now, because that is the longest duration, it will always have the least amount of float. Now, this float will normally be 0. However, there are exceptions to this. If we have an externally imposed deadline, then it is possible that we could have positive or negative float. I used an example before of if we have an externally imposed deadline of 45 days, that would be the late finish of activity F. So the entire project has 45 days. That would mean that every activity along the critical path would have 7 days of float. And for the two activities not on the critical path, we would go ahead and add 7 days of float. At the same time, we could have negative float. So if we had an externally imposed deadline of 30 days, then we would have negative 8 days of float along the critical path, which obviously would not be a good situation. Typically, though, the critical path will have 0 days of float. Any delay that you have along the entire critical path will delay the entire project, and it will push it past its original scheduled deadline or end date. If we have float within an activity, those activities can be delayed by that amount of float, and it will not delay successor activities or the project overall. This is your opportunity to go ahead and practice what we've just gone over. Please go ahead and pause the video until you've completed this exercise, and then we will review the answers. So having conducted a forward pass and a backward pass, these are the numbers that you should have come up with.
As you learned in class, there are two methods of doing a network diagram, calculating a forward and backwards pass, in other words. There's the one-day method, and that's what you learned in class, and then there's the 0-day method. This video deals only with the 0-day method. Now, depending upon your mathematical approach, you may use either method for the PMP exam. However, it is recommended that you know 1-day method scheduling and how it affects the network diagram, and you know 0-day method scheduling and how it affects the network diagram. So what we're going to do, as I said, is just deal solely with the 0-day method scheduling. So this is very similar to the network diagram that you saw in class. So now let's go through this network diagram, only now we're going to do a 0-day method. The difference between the 0-day method and the 1-day method is that we start the project on day 0. In the 1-day method, we start on day 1. So let's do a forwards pass through the network diagram, and we'll start on activity A, and its early start is 0 because nothing comes before it. Now to calculate the early finish of an activity, early finish is determined by adding the duration to the early start. So we have an early start of 0, we add 5, which is the duration, and we come up with an early finish of 5. Now when you have successors in the 0-day method, you're going to take the early finish of its predecessor, and that becomes the early start of the successor activities. So in this case, since we have only one activity preceding activities B and C, the early start of both of these activities will be 5. We do the exact same thing that we did in the first activity with activity B, so we have an early start of 5. We add 10 to it, and that becomes an early finish of 15. On activity C, it starts on 5, and 5 plus 12 is 17. So we go to activity D. Its predecessor finishes on 15. So now D is going to start on 15. We then take 15, early start, and add 15 to it, and that gives us 30. Now on activity E, we have to go back to our rule at the top. Early start of successor activities is equal to the latest finish of its predecessor activities. And so now we have two activities finishing on different days. So 17 is the latest early finish, and that becomes the start of activity E. Activity E, start of 17 plus a duration of 4 is 21. Now let's figure activity F. Since I have an early finish of 30 on activity D, and that is later than the early finish of 21, then activity F starts on 30. 30 plus 8 equals 38. So now to start a backwards pass, we simply take the early finish of our last activity, and we drop it down, and that becomes the late finish of that same activity. So the rule on the way back is we take the late finish, subtract the duration, and that becomes our late start. That's what the rule says there. Late start is determined by subtracting the duration from the late finish. So we have 30. Now, when we have a split or a divergence here, you'll see that activity F must start on day 30, so activities D and E have to finish by day 30. Remember, we're using the 0-day method here. So let's calculate activity D's late finish. And we have a 30 minus 15 gives us 15. Let's go down to activity E. We have 30 late finish minus 4 gives us 26. So again, we have our rule here. So now we're trying to calculate activity B's latest finish. So now let's go back to our rule up at the top. So I have a late finish of predecessor activities is equal to the earliest late start of its successor activities. Well, activity B has two successors. The start of each one of those is 15 and 26. 15 is the earliest late start, so that becomes the late finish on activity B. Now we calculate backwards here. 15 minus 10 equals 5. Now down on activity C, its successor starts on 26, so the late finish of activity C is 26. 26 minus 12 is 14. So the last one we're trying to calculate here is the late finish of activity A. So you'll notice it has two successor activities. So the latest finish of the predecessor is equal to the earliest late start of its successor. So the earliest of the late starts of activity B and C is 5. So the late finish becomes 5 on activity A. 5 minus 5 equals 0. And so that, in a nutshell, is zero-day method scheduling. As you can see, there's no adding of one or subtracting of one. This can actually help you calculate a schedule much quicker as there is less math. Now, the float rules are exactly the same in both methods. We take and calculate the float by taking the late finish and subtracting the early finish. So on activity A, late finish of 5 minus early finish of 5 is 0. On activity B, late finish of 15 minus early finish of 15 is also 0. Down on activity C, 26 minus 17, that's 9. Activity D, 30 minus 30 is 0. Activity E, 30 minus 21 is 9. And activity F, 38 minus 38 is also 0. You may remember from class that you calculate the critical path by the path that has the least amount of float. And so in this case, our critical path is A, B, D, and F.